Hello, so I'm just going to make a quick video on this heat pump that you can see behind me over there today. So this is a heat pump that I helped design together with my friend Tristan Lee from Open Energy Monitor. So this house behind me, this beautiful house, belongs to a friend of mine who did an extensive renovation to it about a year ago. So I helped him design and install the system. It's been installed over a year now, so I thought it'd be a good time to do a little update video about the system and what performance it's got, and we'll talk a little bit about the house. So as you can see here, this house it's in a very exposed location here in Snowdonia. It's pretty cold here today. We're up at about just over 300 meters. It's a solid stone property. And he did an extensive extension and did quite a bit of energy efficiency measures while he was doing the renovation. But let's have a quick look at the outside of the heat pump, and then we'll go inside in the warm and I'll give you a little tour around the house, and we can have a look at the the inside parts of the heat pump and discuss take a look at the performance. Hope you can hear me okay. It is rather windy today. It's a few days before Christmas and it is cold out here. So here's the heat pump. So if you watch some of my other videos, this heat pump may look pretty familiar to you because it is the identical heat pump that I've got installed in my house. It's a Samsung Gen 6 5 kilowatt R32 heat pump. Nice, small, simple heat pump. This part of the house here where the heat pump is attached onto, this is the new extension part. Yeah, it's quite an interesting house to do a heat loss calculation, because when we did the heat loss, he hadn't finished the house, so we couldn't go and measure the rooms. We just had to do it off the plans. So obviously the new bit of the house here is really well insulated, done to a very high modern standard. And then the old bit of the house here, this is the old solid stone bit. Solid stone part of the house, so that this house obviously had a much higher heat loss, so it's quite an interesting heat loss design. But this part has been insulated. You can see here this is external wall insulation. Might be able to see it under there. So it's actually quite reasonably large house now, with the full area with the extension included. This house is actually up for rent at the moment. If anyone would like to come and stay in this house, I'll put the details up at the bottom of this video. Cool, let's go in the warm and take a look at the indoor bit. So this is the new extension part of the house, which is really nice. He did an amazing job, did all the work here himself. But the heating for the entire house is all underfloor heating. So he did a really extensive job fitting underfloor heating to the whole house. So that's what the heat pump is connected to downstairs, and then upstairs there's radiators. So let's have a quick little walk around here. So now we're entering the solid stone part of the house. As you can see here, they've got the solid stones exposed. You can see all the solid stone around the fireplace. There is a fantastic view out here, which is beautiful, but it does mean that this property gets a lot of weather. So let's just go and have a quick look upstairs at the radiators. So like I said, it's all running open loop, so the radiators are running at the exact same temperature as the underfloor heating, which is currently 30 degrees. So the radiators here have been sized to be able to heat the rooms up here, at the same temperature as the underfloor. So this is the bathroom radiator, and in here also the towel rail is plumbed in to the heat pump. That's nice and warm, 30 degrees. We've got the bedroom, 1.2 meter by 600 radiator in here. And like I say, if you like the look of this house and would like to come and stay here and experience living with a heat pump in the mountains of Snowdonia, North Wales, the details will be in the bottom of the video. This room here has actually got two radiators. I think that's an 800 by 600, and that's a small little radiator there. Again, that's that lovely view out that way. And then I think that's, one more here. This was actually one of the old radiators that we reused from, this property was heated by oil, which was taken out during the renovation, and this was one of the old radiators that I managed to reuse. But yeah, these radiators are heating the space just fine, you know, even with that low flow temperature. Okay, so let's go and have a look at the plant room for the heat pump. This is just through here. It might look like there's quite a lot going on here, but it's actually a really simple system. This property's got a private water supply, so all this stuff here, this big pump, this UV filter, that's all to do with the private water supply. The only heat pump bit is the cylinder and the underfloor manifold. So the system is fully open loop, as you can see on the underfloor heating. There's no actuators at all in the radiators. There's no zone controls, no thermostats. The radiators upstairs do have TRVs, but they're left fully switched on. So we've got flow that comes from the heat pump outside. Oh, you can see it's about to go into defrost. Can you see it's frosting up a little bit on the side? That's perfectly normal. It's about 2 degrees outside today. Flow coming in here goes to the pump. Samsungs have the primary pumps inside the house. Then the flow goes into this 3-port valve where it gets diverted either into the cylinder or into heating. And the flow, it goes straight into the underfloor manifold, or it tees off and it goes along here and then up to the radiators upstairs. The return comes out of that, out the underfloor heating, tees together for the radiators, through the mag filter, through one of our heat meters, through the Samsung flow sensor, and then back out to the heat pump, and a couple of automatic valves up there. So yeah, nice simple system. The only control we're using is the Samsung controller, and that's located over here in the living room. There we go. That's the Samsung controller. So we'll see it's running at a flow temperature of 30.8, nearly 31 degrees, and maintaining a temperature of 19.6. And the hot water is set to 50 degrees. So let's have a look at the settings on this heat pump. So we'll just get into service mode, hold down up and down, and enter in the default code, which is 0202. And then if we scroll down to field settings, water law, which is Samsung's name for weather compensation. It's not the easiest controller to use this. So let's have a look at the outdoor temperature. So we've got a low temperature, which is 16 degrees. So that'll be, low means the water temperature will be lowest when it's 16 degrees outside, and the water temperature will be highest when it's -2 outside. So the temperature when it's 16 degrees outside will be 25 degree flow temperature, and then when it's -2 it'll be 33 degrees flow temperature. So that's a very low flow temperature, but we've had some pretty cold temperatures this winter and last, and it's been able to heat the house, you know, just fine because of that extensive underfloor heating. So the hot water system in this house is actually distributed in a range of different pipe sizes. So the hot water comes out of the top of the tank cylinder there and into that little black manifold, and then those little microbore 10mm pipes run to individual taps, and the reason for that is that the taps get hot a lot quicker when the pipe work is smaller, and less heat is lost by heating up a big, 22mm bore. This is the hot tap. As you can see, there's plenty of flow there from a microbore pipe. So this house, it's not a passive house, far from it, but a friend did incorporate as many energy saving measures as possible, and one of those was extensive air tightness measures. So we had air tightness tape all over the house to seal it up, and also an MVHR system in every room. There's a little duct there which ducts to a little MVHR, unit upstairs. So the MVHR system means the house has got really good ventilation, but the heat in the house is not lost during ventilation. So basically the exhaust heat is passed to the air that's coming in via the heat exchanger inside the MVHR. So you get nice fresh air, but without the heat loss. So let's have a look at the data to see how this heat pump has performed. So for space heating, it's averaged a SCOP, a seasonal coefficient of performance, of 5.1, which is fantastic, which is amazing result. This is about as good as it gets when it comes to heat pumps. The performance of this system puts it as the third highest performing system on heatpumpmonitor.org out of the 38 systems that we have that we're splitting out hot water and space heating, and we have a full year's worth of data for, which is fantastic. There's out of those 38 systems, there's some very, very high performing systems. So for this system to get third, particularly because Samsung is it's a budget heat pump, but it has performed very well because of the underfloor heating system. Really, for hot water, it's averaged 3.6. And a combined of 4.7. It is 8th on heatpumpmonitor.org out of the 99 systems that we have a full year's worth of data. So these are the amount of electricity and heat that the system used for space heating and for hot water and for combined. This data was collected using an open energy monitor, level 3 monitoring system. So it's got a MID approved billing grade heat meter to monitor the heat output, and the electrical input is actually measured on this system using an open energy monitor EMON-TX4 energy monitor with clip-on CT sensors. This system, because it uses CT sensors, is not MID approved, but we've done internal testing and to see that it does meet the 1% accuracy standard, the MID standard, but we haven't had it officially approved. And for that reason, we don't show this system by default on Heat Pump Monitor. We're very strict with the data on Heat Pump Monitor that only systems with MID meters get shown. So if you do want to see this system, you'll have to check the other metering box to be able to see it, or you can go to that direct link below. So running costs, if this system was on a standard tariff, it will have cost £885 for the year to run, with a cost of heat of 5 pence per kilowatt hour. The cost of heat delivered from a gas boiler is 7 pence per kilowatt hour. So even on a standard tariff, it's still cheaper than gas. My friend has been running the heat pump for the whole year on Octopus Agile Smart Tariff. So the actual running cost for this system is £559 and 3.8 pence per kilowatt hour of heat delivered, which is a very, very good price. And I'll come on to in a minute why Octopus Agile has been particularly beneficial for this system. Here's a little comparison of how much the system would have cost on gas and how much it did cost on Octopus Agile. So that's a considerable saving, and this is just in year one. A mains gas connection is not available for this property, so the only options apart from a heat pump would be oil, bulk LPG, or direct electric, all of which are considerably more expensive than mains gas. And in terms of cost of heat delivered on the Octopus Agile tariff, this is the second cheapest air source heat pump for cost of heat delivered on heatpumpmonitor.org. So that's coupled with the high efficiency performance of the system, and also the fact that it's been optimized for Octopus Agile. So let's have a look what that looks like. So this is a typical winter day when it's 5 degrees outside. So the heat pump is running continuously. The little spikes in flow temperature you can see is hot water cycles. You can see they're shaded, the little shaded section on the graph, and the little drops in the flow temperature are defrost cycles. You can see it's defrost cycle 1, 2, 3 defrost cycles overnight. And you can see it's maintaining
an average of 21.5 degrees in the house, with an average flow temperature of 30.8 degrees. So this is where the high efficiency comes from. Having that big underfloor heating system allows it to run at a low flow temperature. If you notice here, between 4 o'clock and 8 o'clock here, the system is switched off entirely because there's so much thermal mass in the underfloor heating system. The internal temperature drops very little. Over that time, it dropped 0.9 of a degree, so not even 1 degree. The Agile Tower varies every half an hour. It changes from day to day, but every day between 4 and 8, there's always expensive tariff period. So this heat pump doesn't run during that time period. Another way of getting around this would be to fit a home battery. Then you could run the heat pump, steady state all day, and use the home battery to cover the consumption for that period. So let's have a look at an extreme example. This is always interesting. The coldest day of the year, when it went down to minus 4.2 degrees overnight. The average on this day was minus 2 degrees. So yeah, cold day, below the design temperature of this system, it dropped down to, and the heat pump was able to maintain an average of 21 degrees in the house, and even with turning the heat pump off between 4 and 8, it only dropped by 1.5 degrees. So yeah, even on the coldest day of the year, turning the heat pump off for a few hours at peak time was not a problem. And until I saw the data from the system, I've always been a little bit skeptical as to how much load shifting you can do with a heat pump. And that's been my experience with the radiators anyway in my house, which is not particularly well insulated. If I was to turn the heat pump off entirely from 4 till 8, I'd really notice a significant drop in indoor temperature, and the heat pump would then have to work harder to catch up in the evening. But in a well insulated house with an underfloor heating, looking at this data shows that you can definitely turn the heat pump off during peak times, which makes it very low cost on the Octopus Agile tariff. These spikes you can see during the period the heat pump is off. It's actually the heat pump running anti-freeze cycles, where it circulates water around the pipes outside to stop them freezing. And it takes a little bit of heat from the hot water tank. You can see a little shaded area there. And the shaded area means the 3-port valve was moved over to hot water. And it's taking a little bit of heat from the hot water cylinder to circulate around the outdoor pipework, just to make sure the heat pump doesn't freeze, because the temperature is well below freezing at that point. If we have a look at the heat demand profile here, we can see that the heat pump is about bang on for this property. Possibly it could be slightly undersized to maintain 21 degrees at -3, but we don't really have, it's very unusual to have -3 for a full 24-hour period. Even on the coldest day of the year, when it went down to -4, the temperature did increase during the day, so the average for that day was only -2. So taking that into account, I think this heat pump is bang on sized. This installation was not without its issues, actually. One issue that we had was nothing that we did on the installation, but after the heat pump was installed, it was making like a whistling noise. And I'm very familiar with this heat pump because I've got this exact same model of heat pump for the 5 kilowatt Samsung Gen 6 in my own house. So I was very familiar with the noise that it should make, and I was convinced that the noise it was making was not normal. That was also picked up by my friend. It's quite it was a sort of noise that gives you a headache for a while. I'll play a little clip of the noise here. So we got Samsung, the unit was under warranty, and we got Samsung involved, and they sent an engineer out who confirmed that there was a problem. And then they went to replace bits of the refrigeration circuit where the noise was coming from. First they thought it was the evaporator. The noise was still there. They then, via process of elimination, traced it back to the 4-port valve, which I've highlighted with the arrow there. This is the valve which can reverse the refrigerant to make the heat pump go from heating to cooling. It's used for defrost mode, but this heat pump, like all heat pumps, can also deliver cooling if needed. But anyway, with the new 4-port valve in, and the system repressurized with R32 gas, whistling noise is now gone, and all that warranty work on the heat pump has not affected the performance at all. I should say the heat pump was working just fine with this noise. It was getting great performance, but yeah, this noise was you couldn't live with it. But now the heat pump is fully fixed, and it's all working well. Data we've looked at so far has all been captured with the Open Energy Monitor third-party monitoring system. But if we compare the data with the data captured by the Samsung onboard monitoring system, there's quite a discrepancy. Samsung over-reports the electric input by 13%, and they under-report the heat delivered by 19%, which results in the COP being under-reported by 32%. My heat pump also under-reports the COP delivered. We've seen significant discrepancies in the onboard monitoring of heat pumps from all makes and models compared to building grade heat and electricity meters. So take onboard monitoring figures with a big pinch of salt. So you've seen the house, and now we've looked at the data. But what's this heat pump really been like to live with? So let's hear from my friend Conrad and his partner Sarah, the homeowners of this beautiful house, who are there currently in Southeast Asia. Let's hear what they've got to say.
Hello. So Glenn asked us to make a little video talking about our impressions and perspective of the heat pump installation and living with the heat pump, and having lived in the same house before and after with an oil boiler and then the heat pump. So the house beforehand, it's an 1800s stone built with 60s extension, all pretty poorly insulated. We had a lot of damp, we had a lot of, it was cold. If you didn't have the heating on, you could make it warm, but it cost a lot to heat with the oil and it wouldn't stick around. The house now is both extended and renovated to quite a high standard, and so it's well insulated. It's got a lot of emitter area with the underfloor heating, so it's not just a straight install without the fabric of the building being changed. It's not apples for apples, more apples for bananas, I guess, but we can only give our opinions on the whole experience. So with the installation, I guess a bit of background. Glenn's a really good friend. We used to live together at one point, and Tristan's been very kind and helped out as well. And he did a heat loss calculation for the house, or what was planning to be the extension of the house. And I built the extension and the renovation and changing the fabric, and installed underfloor heating on a liquid screed, and under, again, advice from Glenn and Tristan, I put in sort of as much pipe as I could. So it's 100mm spacings on the underfloor heating pipe with 50mm anhydride screed. So the heat transfer is really good there, and there's a lot of surface emitter area, which means the flow temperature can be really low. So even at its coldest, the flow temp's only 30-31 degrees, which means it's really cheap to run. The plumbing side of things I did myself under Glenn's guidance. He was really great, and thanks so much, Glenn, for always being at the other end of the phone if I was stuck or needed some advice and things, and telling me how to buy, what to buy, help me buy all the components and fit it together. So I did the actual plumbing and installation myself. I am a builder, so I'm pretty practical and handy at those things, but I'm not a plumber, and I'm certainly not an electrician, or so all the OEM, the Open Energy Monitoring software that Glenn and Tristan design and build, that allows any of you to look at the data from how the heat pump's performing, that is all installed by Glyn. That's sort of beyond my little brain. But overall, it wasn't too traumatic an experience to put in, and I decided to do it myself, because as opposed to trying to get a grant or something like that, because in the end, buying the components and doing the install, it wasn't any more expensive than, you know, getting the bus. In fact, it was a bit cheaper than getting the bus scheme and getting it done through a company. And I had control over a good design, making it really efficient and cheap to run, which I'll come on to in a bit. Whereas if I'd gone through the bus scheme, or there are some grants where I could get it done completely free. I've seen a lot of installs, because I'm working on the houses, that I've just gone slap bang in, and they don't run very efficiently. And I do have friends with these systems, and it's no cheaper to run for them. So living with it before, obviously the house was, the fabric was different, the surface there, but we had an oil boiler, and I hated the oil. Anytime the oil ran out, I had to bleed the system. The house stank of oil for days. Other issues, just getting the oil. Deliveries was always a big lump sum payment. It was very reactive, so you'd have to put the heating on. You know, you'd get cold, you put it on, it would get hot, you turn it off. It was that kind of system. We had it on a timer as well, but it just didn't. I should bring Sarah. She'll mention, you know, she's lived with it, and she was the one who really didn't enjoy the heating. You need a bit of room for Mama.
Before, it was always really, really cold. Every time we go into the house, we'd have to wear a jacket, and sometimes it felt colder than it is outside. Yeah, and it was really, really damp as well. But now it's completely changed.
I guess in theory, I could have had the house a lot, you know, hotter all the time with the oil boiler, but the expense of that, I mean, some of that will be the insulation of the fabric, as opposed to how we're putting the heat in. But I guess the heat pump is now on all the time, just trickling heat in, so it's a consistent heat as well. So now, living with it, what are your thoughts?
Oh, it's perfect temperature now. Really, really nice. Really pleasant to live in. Yeah, I love it.
Right. Hot water, is it hot enough?
Hot water is perfect. Hot water is hot enough. Only slight problem is, you know, if all of us decide to have a bath or shower at the same time, then, you know, we do run out of water.
What you mean is that if we have a bath, and then another bath, and then a shower, all in an evening, we can run out of hot water. But that is because, for the economics of it, I'm on a Octopus Agile tariff, so it's cheap at night, it's more expensive at certain hours, so I don't have the hot water set to just recharge the tank whenever the temperature drops. It's on a timer, so it only heats during the cheap hours at night and in the morning. So if you use 250 litres of hot water, you have to wait, because I've got it on a timer, for it to heat up again. I also don't have the heat pump running during the most expensive hours, again making it very cheap to run.
I was a bit worried that, you know, it won't be warm enough, and, you know, the settings, and you know, if it's a cold day, I'd like to turn the heating up a little bit, but I've not had to worry about, you know, the temperature at all. It's just been like constant. It's just been really nice.
I mean, that should hopefully be the weather compensation when it's on a curve, so it will put in a warmer flow of water into the underfloor heating when it's colder outside, so it does that adjustment automatically. I mean, that was the aim. Sarah wanted a warm house. I wanted a house that didn't cost a fortune to heat for her, I guess. You know, you could argue that a heat pump is expensive to install and put in, and I'm not counting my own time in this, but the heat pump itself was about just under 5,000, the cylinder 1,000, maybe 1,000 in components and gubbins, probably some other ancillaries that I've not thought of, say another 500, but you know, we're under £5,000 for it. Sure, we don't have gas in our area, Sure, an oil boiler would be a simpler install and a bit cheaper, but overall I don't think it'll take very long to make up that difference, and the comfort level between the two is incomparable. And to be honest, friends come over and they sort of sigh. Well, I'm thinking of one friend, Matt, if you ever watch this, and every time he comes in the house he just goes, "Oh, it doesn't feel like an old Welsh cottage," kind of thing, which is lovely. And it's a huge amount of this is down to Glyn and Tristan's advice and their help, and they're lovely, wonderful people, and they really care about what they do for the, from an environmental standpoint, and they're so, helpful in all the ways. So if they do, I have had other friends asking me, lots of people asking me advice about this, and I tell them what I can, and then I sort of suggest, but if you're going to do it, I'd speak to these guys about getting a system design, because it works so well, and it's, if you've got some practical skills and you can do some of the install, or if you have a plumber who's willing to do it, but you need some advice on a well-designed system, like you can see, it's a cheap unit. It's not an expensive valence system or anything like that. It's one of the cheapest units out there, and it's performing so well. If you look at the stats on the open energy monitoring, it is one of the best performing in the country. So that's just down to the system design of these guys, and of course the emitter area and the fabric of the house. But yeah, thanks so much, Glenn. I hope this helps. Bye. Say bye. You say anything?